Tangent line. We'll get it. I'll take it. All right, a tangent line intersects a circle at exactly 1 point, called the point of tangency. So A is our point of tangency. The tangent line is the line AB. So we already covered this when we did our definitions, but I just wanted to cover it again. Now, here's the deal with a tangent line. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So that's what that picture is illustrating. So a tangent line touches a circle at only 1 point if it is perpendicular to the circle. And what we use to determine that is the radius and the tangent line. Do the radius and the tangent line form a right angle? A lot of times what is going to become involved in these problems is a right triangle. If we also draw a segment from P to B, that we will use the relationship there with the Pythagorean theorem. Okay, so let's look at the first set of problems there. Determine if AB is tangent to the circle P. Let's look at number 2. Okay, let's look at number 2. So what we're looking at here is AB is potentially our tangent line. If it is tangent, then it forms a right angle with the radius. So we're going to assume right now that there's a right angle right there. If there's a right angle right there, the Pythagorean theorem should hold true, meaning a leg squared plus the other leg squared is equal to the hypotenuse squared. Now, is the hypotenuse 5? No, that does not make sense because the hypotenuse is supposed to be the longest leg, right? But all they have marked there is that it's 5. Well, they are expecting you to use your knowledge that you can put a radius anywhere in the circle that you need to. So that's also a radius, right? Well, the radius of our circle here is 11. So that distance is 11. So the hypotenuse is really how long? 16. So the question is 11 squared plus 14 squared equal to 16 squared? Well, use your calculator. Check. 11 squared plus 14 squared is 317. I don't think that that is equal to 16 squared. 16 squared is 256. It is not equal. The Pythagorean theorem does not hold, so that is not a right triangle. So no, in this case, AB is not tangent. So if it were true, if the Pythagorean theorem worked, if the left side of your equation does equal the right side of your equation, then you do have a right angle, so therefore it is a tangent line. Okay, moving on to the next set of questions here. We are going to assume that it is tangent. We're going to assume that it's tangent, and we're going to use that information to find x. So let's look at number 4. Look at number 4. We're going to assume that that's tangent, so the line that is completely outside the circle. Completely outside the circle is the tangent line, so where that meets the radius, or it could meet a diameter, that's where your right angle is. So that means that this side, LK, is the hypotenuse. So let's set this up. We've got leg squared plus leg squared. X squared plus 11 squared is equal to, once again, is the hypotenuse 7? No. We got to do the same thing we just did in the previous problem. Now, it's completely coincidental that the radius is 11 in both cases. So this hypotenuse is actually 18. So we've got our Pythagorean theorem. We can proceed to solve this equation. 11 squared is 121. 18 squared is 324. So when we subtract 121, x squared is equal to 203. The opposite of squaring something is taking the square root. 203 is not a perfect square, so we either leave it as the square root of 203, or we take the square root and round it. We don't have any instructions for our rounding, so let's just go to 3 digits after the decimal. That 8 rounds that 7 up to another 8. Check and make sure that it makes sense. Okay, we were looking for one of the legs, so really the only thing that we can do is we can make sure that it's less than the hypotenuse. And the hypotenuse is 18, so that checks out. I mentioned that once again to keep you in the mindset of, if this is a multiple choice question, I should look at my answer choices, and even if I don't remember exactly how to do the problem, I should be able to eliminate probably at least one of the answer choices. Usually they will put one on there that just doesn't even make sense if you think to check properties of right triangles. The hypotenuse must be the longest length. Okay, let's do another one. We are going to do number 8. Okay, let's do number 8. When we look at number 8, the tangent line is KJ. Okay, that's the only one that is completely outside of the circle. It is intersecting this time with a diameter. So where they intersect is where your right angle is. So we point to the hypotenuse. 25 is our hypotenuse. Our legs, one of them is 7. The other one has an X, but notice that X is purposefully between J and L. That means that it's only that part. If we need the whole thing, well, that's radius. So if that's X, then the other part is X. So that whole leg length is 2X. So we're going to square 2X. Now, here's where you have to be careful. If you square something like 2X, you have to square the 2 and you square the X. And I think 25 squared is 225, or is that 15 squared? Nope. Ooh, yeah, that's 15 squared. 625. Let's try again. Okay, we're solving for X. So we subtract the 49 from both sides. 4x squared is equal to 625 minus 49. That's 576. Divide by 4. X squared is equal to 144. So that means x is equal to 12. Square root of 144 is 12. Now, that's all the instructions asked us to find, was to find x, but I would make sure that it, again, makes sense. If x is 12, then that's 12, and that's 12, and the whole leg here is 24. It is a leg, so it must be shorter than the hypotenuse. It's only 1 unit shorter, but it's shorter. Okay, there's no true restriction on that. We just need to make sure that it is less than the hypotenuse.